What it do, party people? We are live. What's up, y'all? I see, um, as y'all can see from the title, we're working on Unit 6, Lesson 9. Do me a favor before you watch this, like, share, and subscribe with the subscribe to the channel. Been dropping a lot more videos lately, a lot more content. I'm gonna do some stuff outside of my classroom stuff as well. Also, if you have any requests for a specific topic, let me know. And if I don't have the topic already, I could do a video on that. Or if you're looking for a specific topic, I can share that information with you as well. But let's get right into it because I don't want to hold y'all too long today. This one is talking about characteristics of exponentials, right? And so remember, one of the things to recall about exponential functions is that they grow a certain way. I'm not going to do the bridge because I don't really want to do it. It's not as important to me. So how would you express the relationship between the quantities pictured? Notice they're same as three dots in both of them, but they just are positioned different. I won't go too far into that one as well. But I will do this. So we have here some multiplication and division equations. Fill in the missing pieces. The first one is completed. Okay. So notice this is like fact family. 6 divided by 2 equals 3, and 2 times 3 equals 6. Notice division and multiplication, they're inverse operations or opposites. Okay. So you want to remember that. That's how we work in these. So we start out with 20 divided by 4 equals 5. So we want to use a multiplication equation. And we want to take these two numbers. So let's say you could say 4 times 5 equals 20. So you could say 4 times 5 equals 20. Or you could say 5 times 4 equals 20. Same thing. Number 3, notice it has multiplication here. So we've got to take and make a division equation. Well, we want to do this, start with this 18. And so we could say 18 divided by 12 equals 1.5, or we could also say 18 divided by 1.5 equals 12. Either one of those works. Notice when I get over here, it's a little different. It says 9 divided by 1/4 equals 36. So I could say 36 times 1/4 equals 9. That one is pretty much how you would have to do that one, because 36 divided by 9 is not 1/4. Okay. Or 36 times 9 is not 1/4. Notice this one as well. 12 divided by 15 is what? 0.8. Or you could say 4/5 if you want to write it as a fraction. 4/5. So we could also say 0.8 times 15 equals 12, or we could say 0.8 times, actually we would have to do that one like that. All right. But you could also do the 4/5 as well. So I did A and B. So A divided by B equals C. So then we could say C times B equals A. And depending on the scenario, I would leave it like this though. All right. So that's that. Let's move right on because I want to get to the next activity because it's longer, much longer. Activity 1. Activity 1, notice you have these 5 graphs, right? And these 5 graphs show you the amount of, so this scenario is basically, it says some different medicines were given to patients in a clinical trial, and the amount of medication remaining in one patient's bloodstream was measured every hour for the first 3 hours after the medicine was given. Here are graphs representing these measurements. Okay. By the way, I forgot to tell y'all, if you happen to be watching this live, hey, put something in the chat. Thank you for watching live. I appreciate it. So we have this scenario about different medicines remaining in the body, right? And how much medicine remains in the body after a certain amount of time. So let's go on to the next slide. And so it says, for one of these medicines, the relationship between medicine remaining and time is not exponential. Which one? And explain how you know. Okay. So I'm going to do this. What I did was, for this one, I did some tables of values, and so I'm gonna do a table of values for A, one for B, one for C, one for D, and one for E. All right. So boom, boom. I don't know why my lines are, you know what? I probably should do neater lines. Let's go neat lines. All right, so we can say boom, boom. All right, they're not gonna be perfect. Yeah. All right, boom. All right. Let's do one for here. Boom, 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 boom. And then one for here. Boom, 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 boom. All right. So what we're gonna do, we're gonna take the ordered pairs that are given in each graph. I don't want to keep going back and forth, but I'm basically taking these ordered pairs from the graphs, and I got X and Y, right? So this is X. That's terrible. X and Y. So here I have 0 and 45. I have 1 and 15. I have 2 and 5. And I have 3 and 1.67. I'm going to fill these in first before I go and show you how we actually find out. I have 0 and 50, 1 and 10, 2 and 2, and 3 and 0.4. For C, I have 0 and 50. I have 1 and 40. I have 2 and 32. 3 and 25.6. D, I have 0 and 48. I have 1 and 36. 2 and 27. 3 and 20.25. Okay. E, I have 0 and 50. 1 and 30. 2 and 20. And 3 and 10. Okay. So what we're going to do in order to find out whether these which one is exponential and which one is not, we've got to find the common factor. Remember, exponential functions have a common factor. So each y value is multiplied by a specific factor to get the next y value. And so how do we find that out, right? So we're going to create ratios. So we're going to say 15 over 45, and that equals 0.3. I'm just gonna, it's a repeating decimal. Then I say 5 over 15, that equals 0.3. And it is 0.3 repeating, so we could do that. And then 1.67 over 5 equals same thing, 0.3. When I get over here, I'm gonna do 10 over 50. Okay, so 10 over 50. Okay. And I'm going to do 2 over 10, and I'm going to do 0.4 over 2, okay? And so this equals 0.2, I think. I don't have my calculator. Yeah, 1/5 is equal to 0.2, okay? So 0.2, and this equals to 0.2, and this equals to 0.2, okay? So that's the common factor there. Here, we're going to do the same thing. 40 over 50, 32 over 40, and 25.6 over 32, okay? And this is, I think these are 0.8. Yeah, 4/5 is 0.8. So boom, 0.8, 0.8, 0.8. Here, same thing, 36 over 48. 27 over 36, and then 20.25 over 27, and we got to see what these equal. So 36 out of 48 is 3/4, so 0.75, 0.75, and 0.75. So that's the common factor. Here we got 30 over 50. Let's erase that so it doesn't look like 36 over 50. So 30 over 50. I have 20 over 30. And then I have 10 over 20. Well, this equals 0.5. This equals 0.67 because it's a repeating decimal, 0.6. And this equals 0.6 exactly. Okay. So notice when you look at all of these, the one that doesn't have a common factor is E. Okay, because you got 3 different factors right there. Okay, but the rest of them, if we highlight this, this has same common factor, same common factor, same common factor, and same common factor. So what I mean by that common factor is when I take this 45, I multiply it by 0.3, I get 15. 15 times 0.3 is 5. 5 times 0.3 is 1.67. Now remember, the decimals might be off slightly simply because this is 0.3 repeating. Okay, same thing. If I get 50, 50 times 2/10 is 10. 10 times 2/10 is 2. 2 times 2/10 is 0.4. Same thing here. 50 times 0.8 is 40. 40 times 0.8 is 32. 32 times 0.8 is 25.6. Same thing down here. 48 times 0.75 is 36. 36 times 0.75 is 27. 27 times 0.75 is 20.25. So the answer of which one is not exponential, would actually be E. Okay, so E is not exponential because it doesn't have a common factor. Okay. Excuse me. Let's go. Whoa, I didn't mean to stop sharing. Why would I do that? All right, so let's go on to the next one. Question number 2, we have to fill out this table. And by the way, we're in the workbook lesson 6 and we are on page 91. All right, so we're going to take the remaining ones and we're going to fill out this table. So I have A, I have B, I have C, and I have D. How much was given to the patient? That's the initial value or the y-intercept or the vertical intercept. Those are the 3 different ways we say that. So this is 45 milligrams. This one is 50 milligrams. It says, by what factor does the medicine remaining change with each passing hour? For here, I have 1/3, or as I mentioned, 0.33. Okay. Here, how much medicine? Well, let's get to that next. Here we have 2/5 or 0.2. Okay. I think I wrote that wrong. 2 out of 10, 0.2 is not 2/5. Let me erase that. I wrote that wrong. That would actually be 2 over 10 is 1/5. Okay, so that would be 1/5. I got to remind everybody that that's what it is. So now when I look at this, how much is remaining after 4 hours, then I want to go back to that value of 3. So here for A, the amount after 3 hours was 1.67. And if I multiply that by 0.33, then it's going to give me 0.55 milligrams. Okay, if I do the same thing here, that value that I had for 3 was 0.4. And if I multiply that by 0.2, I get 0.08 milligrams. All right. Here in C, the y-intercept was 50 milligrams, and D, the y-intercept was 48 milligrams. I don't want to get caught up on saying y-intercept because it's also the initial value. It's the vertical intercept as well. Okay, and so for C, the common factor was 4/5 or 0.8 or 0.8. And then so if I take the value for the third hour from C, and I say 20.25, and I multiply that by 0.8, I'm going to get, what did I get? 20.48 milligrams. All right. Here in D, I have 3/4 or 0.75. So if I take the third hour, actually, you know what? Hold up, wait. I wrote the wrong number here. I knew that looked strange. See, that's 25.6. So this should be 25.6 times 8/10. Okay. It's still 20.48. Now D, we have 20.25, and we're going to multiply that by 0.75, and I get 15.1875. Okay, so all we're doing to get these values, you get this, how much was given to the patient from the initial value, or y-intercept, or vertical intercept. We get the factor. We calculated that when we wrote all those tables on the previous slide. And then we get this last one. This number that you see right here first, that is the amount of medicine for each medicine that was left in the body after 3 hours, right? And so we take that value, the value after the third hour, and multiply it by the common factor, and then it's going to give us the amount remaining after 4 hours. All right. If you need to, pause this, rewind it, do what you got to do. But that's that. I think we have one more activity here, or a couple more questions, actually. Yes. So here now it's going to ask us, it says, which medicine leaves the bloodstream the most quickly? And in this case, it is going to be medicine B. Okay. And the reason it's medicine B was because medicine B left the body by a factor of there was 4/5. I'm sorry, the common factor was 2/10. And so because this one has medicine B is going to leave the fastest because it had the smallest factor, right? So that factor was 2/10. So what this is saying is, I'm gonna write that factor of 0.2. So that's saying after each hour, there's only 2/10 of the medicine remaining in the body. Okay. The one, so this is most quickly, and the most slowly, this is going to be medicine C, right? Because it had the largest factor. So it has a factor. How do I erase this? Of 4/5, which is 0.8. Okay. So what this is saying is, to explain this, if I look at 0.2, that's 1/5, right? So after each hour, 1/5 of the medicine is remaining, right? Here, 4/5 of the medicine is remaining here, okay? So I can go into details a little more on that, but because I don't have it would be easier to show it if I had a dual screen to show you the graphs. But that's why that's the case, okay? And so basically what is happening is this multiplier is telling us, okay, well, how much more of the medicine, how is the medicine changing, okay? And so because we need to know how the medicine is changing, that's how we determine which one is leaving the body the fastest, okay? Now, this one we're going to go through pretty swiftly, but it's really just a bunch of patterns. So this one, the easiest one, if you notice, there's a pattern of 2 to the 5th, And then there we go, 2 to the third, 2 to the second, 2 to the first power. Okay, 2 to the fifth power is 32. And then, so then we have 16. All right, so now when I go from 2 to the fourth to 2 to the third, if you can see the pattern, notice if I go from bottom to top, 2, double that and get 4, double that, we get 8, double that, we get 16, double that, we get 32. All right, so then now if I take this and I say 32 times 1/2 equals 16. Here, if I say 16 times 1/2, I get 8. If I say 8 times 1/2, I get 4. And then we take this over here to the exponent rules. Notice you have 2 to the third over 2, 2 to the fourth over 2. So here we're going to have 2 to the fifth over 2, which equals 2 to the 5 minus 1 power, which equals 2 to the fourth. And as you can see, that lines up. And then here I get 2 to the sixth over 2, which equals 2 to the 6 minus 1 power, which equals 2 to the fifth power. If I go down here, 2 to the second power over 2, which equals 2 to the 2 minus 1 power, which is 2 to the 1 power. It's just a bunch of patterns, okay? It's just a bunch of patterns. It's not anything that's too deep, but you have to, when you see this on a blank page, you have to really look deeper into it to look at what the patterns are. Once you see the patterns, it becomes very simple. When I look at these, I'm going to continue this pattern. So 2 to the 6. So here I have 2 to the 1. The previous was 2 to the second power over 2. So now I have 2 to the 1 over 2, which is 2 to the 1 minus 1, which equals 2 to the 0. Okay, so exponent form, 2 to the 0, which equals 1. And then here I have 2 to the 0 over 2, which is equal to 2 to the 0 minus 1 power. Now that gives me 2 to the negative 1 power. So then if I have 1 times 1/2, I get 1/2. Continue the pattern. 2 to the negative 1 power over 2 is 2 to the negative 1 minus 1, which equals 2 to the negative 2 power. So that's what goes here. And then 2 to the negative 2 power is 1/4, or 1 over 2 to the second power. So then we got 1/2 times 1/2. Here, if we take 2 to the negative 2 power over 2, that's 2 negative 2 minus 1, which equals 2 to the negative 3 power, which is 1 over 8. And then I can say 1/4 times 1/2, which gives me that 1/8. Continue the pattern. I say 2 to the negative 3 power over 2, which equals 2 to the negative 3 minus 1 power, which equals 2 to the negative 4 power. And that is 1 over 16. That 1 is kind of uncute. So I get 1 over 16, which is 1/8 times 1/2. So 1 over 16. Same thing here. Continue the pattern. 2 to the negative 4 power over 2, which equals 2 to the negative 4 minus 1. And that's 2 to the negative 5th power. Okay. So 1 over 32. And then I take the 1 over 16 times 1/2. And I get 1 over 32. Take some time to look at this chart, and just look at the patterns. It's nothing but patterns. If you're looking at this blank, the easiest column to fill out first is actually the exponential form column or the number form column. And then from there, as you can see the different patterns that are going on, you can fill in those blanks. But it's nothing but patterns, and the numbers go in chronological order. All right. I think that's it for this particular video. Thank you so much for watching. Remember, like, share, subscribe. Share with your homies that ain't doing their work. So for those of y'all also that are absent, things like that, this is a very simple way to get caught up on the work and the activities that we're doing in the workbook when you're not in class. So hopefully this helps. Remember, I got the solution to your math problems. Deuces.